So this is a vast upgrade from the last webinar I just did an hour ago. Due to poor timing, I found a nice quiet place in a hallway on, like, at the end of the stairs. We were really lucky, and the people walking past were really quiet. So this is a much nicer place to give a talk. So this is something that I've been actually thinking about for a couple of years and been doing for a long time. We have come across this like trend in the market where people move to the public cloud and they go, hang on a minute, it's costing me just how much? So we've done this for a bunch of folks, and I just wanted to use a kind of simplified version of what we've been doing just to explain how vast the savings of doing this kind of thing can be. So I'm sure, as a lot of people here know and realize, public clouds were popularized on this idea of flexibility and dynamic demand. That's great for some kind of like compute-orientated workload. You have a busy series of business hours, the nighttime's kind of quiet, or you have a major event, and you scale up compute to deliver whatever you're delivering and answer the needs of all this extra throughput or traffic requirement. But then when we start to think about storage, all we really see in the world these days is consumption of storage going up and up and up. I'm showing it here as being something that's kind of linear, but in reality, a lot of the times it's much steeper than that. So when we start looking at some of those data sets, you can start to spot a little bit of a pattern that, hang on, why am I putting this in the public cloud when I don't need that dynamic benefit of the public cloud that I end up paying for? So the public cloud, as everybody knows, has all of these complicated pricing models. So one thing that you will notice with most of them is putting data into a public cloud is free or really, really cheap to do so. But then actually when you want to do something with that data, either do compute against it, read it back, distribute it out, if you're using it as like a CDN source, that costs money. And then on top of just paying to store the data, that part is not, that's no surprise. But all of this traffic and all of the variable costs associated with just interacting with data that you already own can become a bit of a surprise for people. So the kind of workloads that I'm thinking about when I talk about these data sets, it's things like data lakes. They're growing, they get bigger and bigger and bigger. We use them for AI ML modeling. We use them for understanding trend and those kinds of things. It's data that we don't ever get rid of. Or if you're like a media company, all your masters of movies, of audio, it's stuff you can never get rid of. It's stuff that you're always going to keep. So it's well bounded. It's either going to grow over time or not necessarily shrink over time. And then things like backups. Backups can obviously be variable, typically growing again. But they're well bounded and well understood. And then this notion of an active archive, think about the medical industry. You've got to keep data now for lifetime of patient plus a decade or so in certain regions of the world. So that's data that you can just never get rid of. But you also don't want to bury it away in like a tape archive where it becomes really hard to access. So these are the kind of things we see people putting into object storage. Always available, but not necessarily the fastest, storage available. So this is the example I want to talk through. It's kind of simplified down to make it round numbers because my, my mental math can sometimes be a bit slow. So I'm using something that roughly divides easily. But of course, this scales up, and the savings can be, quite dramatic. So any guesses what it might cost to store 2.5 petabytes of data in a public cloud, up for a period of 5 years? Any guesses? It's in the millions. All right. So it's just shy of $4 million to store 2.5 petabytes of data in the public cloud. And I'm sure a lot of brains here now are thinking, hang on a minute, that's an awful lot of hardware. So there's obviously, there's going to be some more detail in a second, but for Ceph, any guesses? And this is managed Ceph. This is something that, as an operator, you don't have to worry about. This is a service delivered where you phone people or you interact with them over a ticketing system, and they look after infrastructure in your own DC or like a co-location center. So it's still delivered as like as a service, but it's quite a lot cheaper. So before I dive into how we got there, this is actually what it looks like. You know, it's a dedicated Ceph cluster in, you know, some data center close to a public cloud. You have your own connectivity out to the internet, so you're in charge or in control of your own bandwidth to deliver to the world, or you can choose to deliver via the public cloud, still the same thing. But then you have this you know, call center on hand that deals with all the operations, deals with organizing hardware to be replaced, all of that fun stuff that, you know, nobody really wants to deal with, and why they chose to go to the public cloud in the first place. So what hardware did we use? You know, it's really easy to build a Ceph cluster that is, you know, pennies per gigabyte. So in this example, and this is the kind of thing that we actually use quite regularly, we used, you know, something like a Dell R740 XT2, so it's quite a nice server. It's quite you know, a balance, 20 large form factor slots, so that you can get good density, but without you know, having too large of a blast radius in any single server. And it's not even a slouch, really. You know, it's got a couple of Intel Golds in there, 32 cores. You know, we've not scrimped anywhere really with this kind of configuration. There's a couple of SSDs in there for the operating system. We also put 4 NVMe devices in there so that we could do the object indexing there, or if need be, you know, if it's a small object kind of workload, it makes some level of sense to have some kind of caching in place. At Canonical with Ubuntu, we typically use Bcache rather than having dedicated walls and DBs, so that, you know, all of the OSD can potentially be cached, not just the DB parts. We also included 3 management nodes to run things like Juju and Maz, so that we can control the deployment of hardware and give us, you know, an entry point into this kind of environment for the managed services side of things. And then the networking was, you know, pretty straightforward. A couple of 25 gigs switches. Again, you know, everything has to be redundant in storage, and then an out-of-band management service for IPMI PXE. So let's look at some of the numbers behind it. And I realize it's kind of late on day 2, so I'll try and be relatively brief over this bit. So in both of these comparisons, or all of the comparisons I'm going to show, everything is list price. So there's no cheating by discounting and using volume savings and things like that. You know, this is literally what you go and get from you know, any provider's website. And, you know, looking at the way that the pricing here is tiered, you can probably guess which provider we're comparing against. So it's, you know, very general purpose. We've not targeted things like the, you know, infrequent access or the cool tiers in the public clouds, but we'll talk about those. And the data set that we were looking at, just for ease of comparison, you know, average object size around 10 meg, and then the entire cluster, we modeled this idea of you could actually rewrite its entire contents twice over the lifetime of the cluster. And I'll cover why that's kind of important in the next slide. So in the public cloud, once you start looking at the various tiers of pricing that you get, by default, the first 50 terabytes is one price, the next 450 is another price, and then beyond it's the same price. Then you have to think about the number of times you are going to put data into that cluster, and how much of the time, or how many reads of the cluster you're going to do. I think in this model we use something like reading the entire capacity of the cluster 10 times over the 5 years. You know, it's this kind of archival workload that you refer to, but you're not actively using every day. So that's how we got to this just shy of $4 million TCO for 5 years. So then managed Ceph. So a little bit of a different way of thinking about things, because you've got to start thinking about having some kind of data center somewhere or some kind of colo facility. And then also start thinking about networking and how that comes into play. So the networking gets kind of complicated just because of the pricing models in public clouds, and taking your, you know, getting transit into a public cloud from a colo facility on a similar campus is kind of easy usually. Even the same metro areas can be really easy. You know, take somewhere like London, and we'll look at a map in a bit. But take somewhere like London. You know, there's a big data center hub in Slough in the west of London. The traditional hub of data centers in London was around the Docklands area. You can get between those in half a millisecond. So you can actually be a bit further away than being proximate, which is kind of interesting. So what did we do here? This is a really basic Ceph cluster. It was 12 nodes, Rados gateway only. We did erasure coding 4+2, to get some benefit out of erasure coding, but without having to, without almost cheating and having this write once workload that reading it back takes a long time, or the throughput's really slow. So we were quite conservative, but I think realistically you could actually go wider with erasure coding. I already talked about having either the indexes or using bcache on NVMe, and the workload's the same. The private circuits between this colo facility and the public cloud are fully redundant. Of course, you could just do one link, or you could even do public internet if you really wanted. If you didn't really care that there could be times when the networking could be congested, so you could actually get quite significant savings by just using public internet or dropping down to the one link. So the costs in this example, the hardware was just around 850,000. We included things like a budget for remote hands, so somebody actually to go and install the hardware physically, to then go in over time and do all the hardware exchanges when components fail and need to be replaced. We didn't include anything for growing the cluster beyond this size, to keep it as a well-bounded example. But as you scale up, your costs in both examples would also scale up. We include things like professional services. If you're not a Ceph expert, you could have somebody come in, do all of the deployment for you, then do a small piece of training and handover, so that an end user can still treat it as a service. Literally just say, hey, go and build this thing over there for me, and not have to worry about it. And then, of course, over time, there is that managerial or management cost. So we included that. The cloud connectivity charges and cross connects is quite, a scary sounding number for what is like 2 fibers across the data center. But you literally have per hour charges to have ports enabled in certain public clouds. So we included all of that too. The data transfer is the crazy one, because as I mentioned before, putting data into a public cloud is free. So if you're reading from a Ceph cluster or any kind of storage cluster that's not in the public cloud, you're not paying to actually read that data into the cloud. But if you're reading out of the public cloud, so if you're writing into your external cluster, that's going to cost you money. So it's something that we included. And then we looked on the east coast of the US for this example, for a data center that was proximate to US East, the Virginia area, and we got a quote for like 150,000 for a 5-year period to provide enough power for this gear and also the physical space for it. So then the next thing that everyone always says is, what about the infrequent or cool tiers? Of course we know that they are cheaper per unit cost. So what does that look like? And what typically happens here is, yes, the per gigabyte or the cost per gig is cheaper, but you get penalized a little bit for actually reading that data back. So there is a slight increase in the cost of the gets and the put operations. It's not huge, but you can still see that it's still a very significant cost. And the challenge here is that you're now entering this world of not like time-bound operations. It's the SLA to read data or even to write data into these kinds of tiers is much wider than it is for like primary storage. So yes, there is a saving there, but it is still more expensive than doing this on Ceph and in this kind of model. So then people say, hey, 5 years is a long time. And we modeled what it would actually look like to do this over a shorter period of time. So we can see the break even here is it's about 9 months. And it's crazy to think that you can go and buy, almost $1 million worth of hardware and go off and deploy a physical thing for a 1-year period, and then throw it all away at the end of that 1-year period when you're quote unquote done with it. And it's still cheaper than this on-demand, hey, I'm putting some data in here. Thank you very much. Here's my credit card. it's crazy to think that, that doing all of that work for that period of time is still actually cheaper. And, the reason for the sort of divergence of the two lines there is, of course, you're not having to pay for things like management and stuff like that for the extended periods of time. So then, apart from the cost, why would you do this kind of thing? It feels like a lot of effort. So one of the things that we find kind of interesting is that over time, different regions of public clouds evolve. So in some regions, you get like next generation hardware, or you get hardware with additional types of like GPUs, and things change over time. So if there's this scenario where a different provider in the same region has kind of interesting hardware, you could use this like external storage location as like a bridge between these different providers, or you can use it as a bridge into your own private cloud. One of the huge reasons for doing this kind of thing is that control over ingress and egress costs. You can expose a cluster directly to the internet over your own transit. And then that way you can see to CDN if that's your kind of workload. You don't have to go via the public cloud or pull from the public cloud, being the most expensive thing you can do. And then the thing that I think is the most important thing here is your business has data, and that data is the most important thing a business can have. There's no data, you can't do anything anymore. So this gives you like quite a significant control over these particular data sets. And if it's the life of patient and longer, it's kind of important and something that you do want to hang on to. So just thinking about the locations of things, because people think, hey, but where are public clouds? Where are the buildings that these places exist? So going to lovely Slough. Sorry, Slough. All of these buildings in this area, well, not all, most of the buildings in this area with these white roofs are all data centers, but sort of mixed in between those are the London regions of the major public clouds. And it's super easy to get bandwidth and connectivity between these various buildings because it already exists, it's in place. You can use services like Equinix flexible connectivity to get between these buildings, and it's like an API call to turn it up once you've got the physical connectivity in place. If you know that you're going to build this kind of solution where you are definitely going to be invested for a few years, you can have those circuits in place much longer. Or if you're if you're already on net, it's plug it in and the provider takes care of the rest of it. And then thinking about the US, the buildings are a bit more spread out because they've got more space. There's a region of AWS in this picture, and then most of the other large buildings around the center are actually co-location facilities that again are on net, and it's quite easy to link them up. So, fully managed or not, this kind of solution, having storage adjacent to a public cloud is really cost effective. And if you think about it, if you're already a Ceph expert and you're already a hardware expert, but you have users that are demanding the flexibility of public cloud, you can mix this up a little bit more and not have any of the managed services, none of the professional services, so it becomes even more cost effective. And then just finally, one day in the future, you decide, hey, I want my 2.5 petabytes of data back. You're going to have to pay 130K just to get all that data back. And I'm sure somebody's thinking, hey, well, they have that, they have devices that you can go and download the data onto, and then they'll ship that device to you. Yeah, but they'll still charge you 130K to get it from the cloud onto that box that then they charge you for on top of that, and then you have to ship and rent and all of that fun stuff. So yes, the public cloud is super, super expensive. So kind of short, I'm sorry, but with that, is there any questions? Yeah, go ahead.
So one of the main advantages of using the cloud is if you have this data and you want to start using it, then you can just immediately send it to a public cloud and then you can start using. what are the lead times for these kind of managed solutions then?
So the biggest challenge right now when it comes to hardware is just getting hardware, right? So you can potentially have like a 3-month wait just to get hardware. This kind of solution is like, it's 12 storage nodes, 3 management nodes. Actually getting 15 servers is not super difficult, but if it was a very large cluster, the lead times on hardware could be, several months. But if you're thinking about this as that data set that you're keeping for a long time that, you've built up over time, you could actually, hey, I know I have this amount of data and plan to move it at a future point in time to sort of free yourself from any, economic changes in public clouds.
Thanks.
Nice. All right, well, thank you very much.